In this unit, we'll learn about the services of the transport layer, which provides various services to the app layer. In previous lessons, we learned about the layer model and mentioned that every layer uses the services of the layers below it. Which services of the transport layer does the app layer need to use? Some apps require 100% transport reliability. That is, the information gets to the receiver accurately. Examples of such apps are file transfer, website navigation, sending and receiving email, etc. Other apps can tolerate data loss up to a point. An example of such apps are ones transferring sound, interactive calls, and in certain cases, also video. Another parameter is the timing. In some apps, timing is all important. Examples can be various online games. In the case of joystick control, timing is critical. Internet calls, Zoom meetings, and so on. Another parameter is the transport throughput. This is especially relevant for multimedia apps where content is received at a certain throughput. Otherwise, the app is ineffective. Apps can be flexible and provide service with high or low throughput. For example, by using a buffer, which collects data behind the scenes and presents the user with content at a set rate. Additionally, some apps require data encoding so that similar users can't do sniffing with the information they collected. An example of such a thing can be navigating bank websites or secretly transferring files. In the following table, we see a summary of transport level requirements needed to appropriately serve the app. When we want to provide a service for reliably transferring data, the mechanisms covering that reliability are relatively complex, so we'll have to pay the price for them in speed, and vice versa. In sending files, websites, emails, and documents, we want the information to arrive fully and reliably, but the throughput and speed are less important. Note that we aren't talking dramatic delays, but reasonable, acceptable delays. On the other hand, video and sound transfer services can tolerate data loss up to a certain point if the throughput and speed are better. There are two types of transport services to various apps. These services are actually protocols in the transport layer. The first service is TCP protocol, Transmission Control Protocol. This protocol assures transport reliability between sender and receiver by using a variety of internal mechanisms within the protocol. TCP-based communication is based on a connection between two end hosts. That is, the two hosts have a process of introduction and allocating resources for communication. This kind of communication is called connection-oriented and contains within it a process of establishing connection and, in the end, disconnecting the two end hosts. The TCP mechanism controls the rate of data transmission in order not to overload the receiver with large quantities of data, what's called flow control. Additionally, there is transfer rate regulation in order not to overload a network at high capacity, which causes general transmission delays. TCP doesn't provide quick reactivity or throughput thresholds or encoding of the data. On the other hand, there is a protocol called UDP, User Datagram Protocol, which allows unreliable data transmission. This protocol doesn't provide reliability, it doesn't provide controls, and doesn't provide transmission rate regulation. Likewise, it doesn't provide data encoding and contains no process of establishing and terminating connection. That's why this kind of communication is called connectionless. So why do we use UDP, which at first glance looks lacking compared to TCP? The reason is that using TCP doesn't promise reliability in that this protocol doesn't send repeated messages. It doesn't promise order and delays, due to the significantly reduced mechanism compared to TCP. Additionally, the message overheads are substantially smaller than in TCP. For that reason, using the protocol is relevant, especially for interactive use, where every delay substantially damages service. But it's possible to tolerate a certain loss of data for the service to still exist continuously. This is the reason why video and audio streaming services, as well as internet calls, prefer to use this protocol, whereas services that are not interactive in real time will use TCP. In this unit, we learned about two key protocols in communication networks, TCP and UDP, which are located in the transport layer. Additionally, we learned when we should use each of the protocols and what are the parameters, such as speed or reliability, we must take into consideration when using each one.